Greetings and hello doctor, my name is Mugilan Anlaki Ravindran. Along with Alisha and Arif as my group mates, we decided to choose a CPU, a central processing unit of a PC, as our product for this assignment, which requires us to simulate heat flow within the product using any suitable software. So the CPU that we decided to use is Intel Core i5-4690, clocked at 3.90 GHz with 4 cores. And the software we used for the simulation and drawing is SolidWorks. CPUs can be found in every computer around the world. And CPUs alone, without a proper cooling system, can reach up to 100+ degrees Celsius, and using a CPU at such high temperatures can severely damage one's PC. Hence, it is important for every CPU to have a proper cooling system which enables it to be used at safe temperatures of below 80 degrees Celsius. The CPU cooling system is usually a forced convection type, as it often comes with a huge fan, and it also comes mainly with a heatsink as well as a base plate, which is the two parts that were drawn and simulated in this assignment using SolidWorks. So the top half of the model drawn is the fin type heatsink with the dimensions of 60 mm by 3 mm by 75 mm in the format of height times width times length. And this heatsink is made out of aluminum 6063-T1. The bottom half is the base plate, which is often connected directly on top of the CPU, and before being attached to the CPU, thermal paste is often applied onto the surface for a much more evenly distributed heat conduction. And the base plate is made out of copper, as coppers are one of the best heat conductors compared to other materials. The total surface area of the aluminum heatsink is 0.037025 meters square. Next, we move on to the simulation. So simulation on SolidWorks can be done by filling in the required details, such as the heat generated by the CPU itself. So for this model of CPU used, it can generate 88 watts of heat. Since this is a forced convection type and it is air cooled, we use the convection coefficient of 50 watts per meter square Kelvin. Generally, in an enclosed space, the convection coefficient of air ranges from 10 to 500 watts per meter square Kelvin at room temperatures of 294 Kelvin. So upon simulating, this is the final result that we obtain. As we can see from the final results of the simulation, the base plate has the hottest area, which is marked red in color, and as it goes upwards towards the heat sinks, the color lightens up from red to orange to yellowish to green and then to light blue and dark blue. Red being the hottest and dark blue being the coolest region of the entire heat sink. And as can be seen, the maximum temperature recorded at the base plate is at 41 degrees Celsius, whereas at the coolest region of the heatsink, the recorded temperature is at 31.2 degrees Celsius. Fin type heatsinks is one of the most efficient heatsinks due to its larger surface area, and it can help dissipate heat much more quickly and efficiently. Using the formula Q over A area, we can find the heat flux. So dividing 88 watts of heat generated by 0.037025 meters square of area, we obtained a heat flux of 2.38 kilowatts per meter square. That's about it from us. Thank you.